Okay, this is SPSS video number 6. Today's topics start with again a little exercise on logical operators for the compute variable, then we'll switch the usage of missing function. Okay, suppose for example I ask you to build a new variable abc equal to when subject is male and year of birth before 1983, the value must be 1. When subject is male and year of birth equal or after 1983, the value must be 2. When subject is female, the value must be 3. Okay, just a sample variable, it has no particular meaning. Okay, in this case you must use the AND operator. Let's see how to do. Transform compute ABC. You can do it in 3 steps using the if. I prefer the other way around, so I prefer inserting the formula sex equal to 0, which means subject is male, and birth smaller 1983 by 1. If you are unsure of the AND operator, you can put extra additional parentheses. They are never bad. Plus sex equal 0 and birth larger or equal 1983 by 2 plus sex not sex equal 1 by 3. Okay, this is the formula. Let's paste it. You check that it really works manually, obviously. So you suppose the person is male and old, so this is true, this is true, everything here is 1, this is true but this is false. So I suggest you to manually check whether it works. Another thing you should check is that the condition do not overlap, otherwise you're creating chaos, and that the condition cover your entire population. Okay. So if you forget this one, it's not good, because female subject in that case will have a value of 0. So if you use this formula and if you forget somebody, those people will have automatically a value of 0. Okay, the function is done. Okay, we should go to variable view and set it to ordinal or nominal according to what you mean with 1, 2, 3. Okay, let's see how to use the missing function. Sometimes you want to do operation on missing values. For example, when subject is male and you build a new variable abcdef equal to when subject remembers his day year is day of first is day of elementary school. 3. When subject remembers subject does not remember his first day of elementary school, but remembers the month equal to 2. no month, but remembers the year, it's equal to 3 when subject does not remember anything. So we are building a variable, 3, 2, 1, 0, a variable which tells us the memory of the subject, how good is it. Okay, clearly here you have to check whether a variable is missing or not. You could check whether the variable is missing or not using something as day L equal 9, okay, because missing is 9. But if you use this formula, I am not completely sure that it works. First of all, you cannot catch the system missing, so if for any reason it's system missing, it will not be called. And second, I'm not completely sure that it works always. So whenever you have to deal with missing values, you either use the record, which has appropriate checkboxes for missing values, or if you have to use the compute, I strongly suggest you to use the missing function. There is a missing function. It's a logical function. It gives you a value of 0 when day L is not missing, and a value of 1 when day L is missing. So it tells you whether day L is missing. It's equivalent to day L is not 9. Wait, no, day L equal to 9. It's equivalent to this one, but it catches also the system missing, and I would say it's safer because you are sure that it really works. Okay, so transform compute variable, reset def. I will write it here so we can see it better. When subject remembers his first day of elementary school, 3. So let me see. Do we have a not here? Yes, we have a not. It should be this one. Let's check into help. Or not. Okay, let's go to statistical. Missing values. Missing returns 1 or 2 if the other has a system missing user value. Okay. So the trick here is to day L, missing day L, okay, equal to 0. Okay. This basically means not missing. Okay. So not missing by 3 plus here, make some spaces, does not remember his first day of elementary school, so missing day L. Okay, here you can put missing day L equal to 1, but you can put also missing day L, okay, because missing day L equal to 1 will be equal to 1 if missing day L is equal to 1. If you leave it like this, missing day L will be equal to 1, the same way. But let's be clear and use this one. Missing day L equal to 1, and missing month L equal to 0 by 2 plus missing day L equal to 1 and missing month L equal to 1 and missing year L equal to 0 by 1 plus the person who has everything missing, so missing day L. I don't write equal to 1, it's the same, Okay, this is the formula. You could note that in these formulas something may be skipped. For example, you may entirely skip this thing here. It's multiplied by 0. This part is always 0. I like to put it because in this way I can really see clearly what is going on. If you want to skip, it will work. Another thing that you can skip is this by 1. Multiply something by 1, it remains the same. So you could skip it, but if you write it, you will see clearly what is happening. So let's take everything, drop it here. Okay. Okay, let's see whether it works. Incorrect variable name. Ooh. Display variable name. DL, month L, year L. DL, month L, year L. There's a mistake here. If I can click. DL, month L, year L. Okay. Okay. Let's see what has happened. Okay, some people have 3, some people have 0, some people have 1. Few people have 2, eh? Okay, this person has 2. Let's check. Day is missing, month and year are remembered. Okay, this one should be 1. Everything is missing 1. Okay, so this is how to use the missing value function. Whenever you have to deal with missing value, it's a good idea to use it. Okay, let's go to something completely different. How to count value within cases. Sometimes I may ask you to count how many variables have a value of 1. Okay. I remind you that it's an horizontal operation, so I will not ask you to count how many people have done statistics, so an vertical operation. But I may ask you to count how many people how many variables have a 1. For example, for this person the result will be 6. For this person the result will be 1, 2, 3. For this person the result will be 4. 1, 2, 3, 4. Okay, so you may want to make additions, inter-horizontal additions, or better, to count how many 1s or how many 3s, how many 7s. Doesn't matter. What you want will be specified later, are there in a certain variable set. Okay. Well, you can do it with a longer sequence of logical expression, also with a transform compute, but it's really crazy. There is a specific function which does it. So for example, suppose I ask you to calculate for each person how many exams of these 6 has the person passed. Okay, the right thing is count values within cases. It means that you count within cases. Can you read? So in horizontal direction. Target variable, how many? Target label doesn't matter. Here the variables that you use. So statistics, APS, marketing, banking, decision theory, commercial law. You put the 6 exam. Here you must tell it to SPSS which values are you interested in. I'm interested in value 1. So I will count how many 1s do I find. Well, 1 because these are yes, no variables. If there were other variables and you were interested in counting how many 7s and 9s and 24s are there, you can put 7, 9, 24s. Or you may want to count how many system missing or system user missing exist. Okay, this could have been a good alternative to the previous exercise. So simply count how many missing or system missing were there in the 3 variables day L, month L, and year L. So continue. Okay, done. Count how many stat, mark, bank, DT, silo 1. Let's see the result. Okay, here. This person, for example, has passed all the 6 exams. Let's check. Yes. It's always a good idea to check when you build a new variable, because you may have committed horrible mistakes and you may find here 7, 9, 23 or all zeros. Okay, for example, let's locate a person who has a 0. Here, this one. Should have passed no exam. Oh, no. Okay. Or if a variable is missing here, it will be considered as not having a value of 1. Okay, so this is rather straightforward. Typically it's used for yes-no questions, so you usually count a yes, but you may use it for other questions which have several different type of answers. Okay, date and time wizard. The date and time wizard, even though there exist date and time functions more or less similar to the ones you have in Excel and Access, the date and time wizard is a much user-friendly way to work with date and times. In fact, we will use only it and we will not use the functions. Let's see typical usage. For example, the typical usage we will do now is you have a day, you have a month, you have a year. Okay, I would like to build a single variable containing the date. Okay, obviously for the people who have some missing values, the entire variable will be missing. So for this person, the variable will be missing. So you have a day, month, year, build a single variable containing the date. Date and time wizard. Okay, here it's a wizard, so it will start to ask you questions. You will not have the usual dialog interface. Well, the first option is clearly not to be used during the exam. You will waste your time. Let's see what we have to do now. We have some data and we want to build a date variable. Okay, here, create a date time variable from variables holding parts of date or times. Okay. Next. Okay, very simply, you drop what you need. First day of elementary school, here. First month of elementary school, here. Oops, no. Ah, sorry, first day of elementary school, here. Okay, remove first, here. It's the day of the month. First month of elementary school, here. No, not year of birth. First year of elementary school, here. Okay, you can see, you can put whatever you want. If you have the day of the year instead of the day of the month, you can put it. Okay, what happens if you don't specify something? For example, suppose I don't specify the day of the month. If you do not specify something, SPSS will make assumptions, so has some default values. If you don't specify the day of the month, for SPSS it's automatically the first. If you don't specify the month, for SPSS it's automatically January. I don't know what happens if you don't specify the year. Probably it will be the current year or even 1900. Here, if you want to may work with times, but usually in economics you don't ever work with times. Okay, next. Result variable, give it a name, date L, and an output format. I prefer this one because I can see the month clearly, so I don't have problems with American European version. Variable label, first. Well, it's the first day of elementary school in date format. Okay, create a variable now. Finish. Let's see. Okay, for many people it's missing because these people had some parts missing. Okay, let's check that they are reliable. Yes, 93, it means that in 2011, yes, it's reliable. Even 96, let's make the calculation. You have done 15 years of school, yes, it seems believable. Okay, let's assign, check this variable. Okay, it's a scale, it's a date variable, it's a scale, evidently. Missing has system missing, so we don't deal with it. Okay, since we will use these variables in the future, please remove ABC and DAF, which are not used anymore. How many? Also. Okay, keep only date L, and let's save the file with another name, date L all B. Okay, it will be used in the future. Okay, so let's make other example. Okay, this is usually something you don't do. We have already seen this. It's calculate with dates and time. Okay. This lets you add or subtract a duration from a date, okay, or calculate the number of time units between two dates. So make the difference between two dates, for example. Okay, so let's start with this one. We have now a date. It's the date when you started elementary school. Okay, and let's try to add 5 years to calculate approximately the date when you started middle school. Okay. Next. So the date when you started elementary school, it's here. Okay, you add a constant. You add either a constant, so 5 years, or you add a variable value contained in a variable. Okay. 5 years. So I'm adding 5 years to first day of elementary school. Addition. Okay. You may add you may add the number of passed exams. It doesn't make sense, but you may add the number of passed exams years. Okay, but in this case, obviously, it doesn't make sense. Okay, this should be approximately the day when you started middle school. Next, a day mid. Create a variable now, and it's simply 5 years after. Okay. Now let's calculate how many days have passed between your first day of elementary school and now. Date and time wizard. Calculate with date and times. So calculate the number of units between two dates. Okay, so the number of days which have passed from your first day of elementary school and now. Okay, date 1 minus date 2. So date 1 is now. There is, you can see, current date and time. It's a special variable indicated with $time. It's a system variable. You don't have to touch it. It doesn't really exist in your file. It's the current time, date and time, minus first day of elementary school. Unit days. Okay, truncate to integer. Result variable AAA. Finish. Okay, this is how many days have passed. For some people, many days. For other. And let's see also how many years have passed. This will check whether it's correct or not. So same thing. In years. Let's keep round. BBB. Okay. So this is the number of years passed between your first day of elementary school and right now, rounded to the closest integer. Well, 97, I'm sure it's a little wrong. 14 seems strange. Well, it could be. Okay, everything else is believable. Okay, so this is how to work with date and time. It's a wizard, so it asks you what to do. The only thing you have to remember is which of the these two menus, which are the most important to use. Okay, and then once you are here, which of these two you could use. Okay, what is extract a part of date or time variable? It's a very simple thing. You have a date and you extract the year, the month, the day, in case you want to use it for further calculation. It's exactly identical to Excel function year, month, day. So something we have already seen. Okay, last thing for this long slide. how to replace missing values. Okay, replace, usually when you have a missing value, you keep it as a missing value, so you don't touch it anymore. However, sometimes you want to replace it because you have good reasons to have an approximate value for it or something like that. There is a specific, you can replace it manually, obviously. There is a specific menu, however, which should be used with care, with caution. Replace missing values. We have here the first day of elementary school, and you throw it here, and SPSS immediately suggests you a method for replacing its missing values. Unfortunately, the methods are really, let's say, not extremely precise and sometimes very rough. The first method which SPSS suggests, so SPSS is suggesting that you build a new variable, day L1, which is equal to the sample mean of day L. So this new variable, for all the people who have a value, will remain the same. For all the people who do not have a value, SPSS will assign the average of the other people. So serious mean. Well, let's try. You can see here a new variable, first day of elementary school, 11, because this person had a value. This person did not have a value, 9.8. 15, 1, 9.8. So to all the people who don't have a value, 9.8. Well, clearly for a day it doesn't make sense, 9.8. But you may assign, for example, 10, which may be a good approximation. Other way to replace missing values are here. Mean of nearby points. So SPSS will take the average between the previous and the next point. It makes sense only if your data are in order. For example, you are working with a time series. If you are analyzing stock prices, for example, and you absolutely must have a value for a day and you don't have the datum, well, you can take the average of the day before and the day after. Or you can take the median of the day before and the day after. It's a little different. Well, or better, depends. If you use only two values, so the day before and the day after, the average and the median are the same. But if you use more than two values, for example 4, so the average of the 2 days before and 2 days after, or 6, the average of 3 days before and 3 days after, the mean and the median are something different. Another thing you could do is linear interpolation. SPSS will build a small linear model, a linear regression model, and try to interpolate the value and find a guess. Linear trend, also similar. There's only a technical difference. So these are all techniques, mean, median, linear, and linear trend, which work well if your data are in order, usually in chronological order. If your data are not in order, the only tool here which may be useful is serious mean, nothing else. However, it's very rarely used. Let's remove these variables which are not used anymore. Okay, I've finished with this slide. Let's do some little exercise. Record variable degree course into variable degree type with values 1 bachelor and 2 master. Do it automatically for the coded answer and then manually for the non-coded other answer, deciding whether answer is bachelor, which is bachelor and which is master. So I ask you to build a new variable, this time seriously because we will use it in the future. So let's build it seriously. It's a recording, different variable. Let me see, degree course. Degree type, change all the new values. 1 goes into 1 and this is a bachelor. 2 goes into 1 and this is also a bachelor. 3, which was a master, goes into 2. 4, which was a master, goes into 2. And 5 was other. So goes into system missing. So 5 was other, goes into system missing. So I remember to modify it. Anything else, So the system and user missing. I will assign a value of 9. Okay. So the only system missing I will have at the end of this modification, of this new variable creation, are the other. Okay. All the non-other will have a value either 1, 2, or 9. Okay, continue. Okay. This is the grid type. Let's fix the variable. Values 1 bachelor, 2 master, 9 missing. Okay, missing 9. It's not scale, it's nominal. Okay, and for this one I will have to fix them manually. Well, in order to fix them manually, I need to see both variables, so I need to move this degree type a little. You can move the variables, obviously. It's even better than Excel in this case. Okay, so business studies, bachelor, design, bachelor, PPE, bachelor. There was really a student of PPE taking this course as optional. Diploma, bachelor, business studies, bachelor. Oh, this procedure could be done also automatically. You could use transform compute if the person has business studies, assign bachelor. Otherwise, leave it like it is. But since the data are not so many, it's usually faster. I'm wondering what does diploma mean. Maschinenbau. Okay, it may be bachelor. Oh, that's missing because I don't know. Here with this little operation you realize that in order to work with SPSS you have to click 3 times here. Okay. Save, because this degree type will be used in the future. Okay, now it's perfect. Build a new variable equal to 1 for the male student who like law and the female student who like computer science, and equal to 0 otherwise. Missing when some information is missing. Oh, this indication is not really necessary, because if you simply use the transform compute, automatically when some information is missing, the final variable will be missing. So here the only way to use this tool is through the transform compute. You cannot use the record here because you don't work with one variable, you work with 2. Or better, you could even use the record. I will show you later how to do it. Let's start with the transform compute, which is much easier. Equal to 1 when male student who like law and female student who like computer science. So reset A, B, C. So male student, sex, who likes law. And now I have forgotten what was the number for law. So either I have the paper handout, the paper code book, or I click here. Law, it's 6. Okay, this one should have a value of 1. But also female student who like computer science should have a value of 1. If you want, you can do it like this. So it's possible and it works to do it like this. Okay, this will work. Okay, otherwise, so this will work. Otherwise, you can do also like this. Put an or in the middle and put a big parenthesis around. So both will work. Okay, let's skip this one. Wait, where is it? And equal to 0 otherwise. Well, since it's equal to 0 otherwise, I could even skip the other people, okay, because all the people who are not considered will be automatically equal to 0. If you really want to write a condition, let's write it. So, when sex is equal to 0 and favorite is not 6, or sex is equal to 1 and favorite is not true. Okay, please take care that all the population is covered. Okay, unless you have explicitly decided to omit some people and you want for them a value of 0, otherwise take care that the entire population is covered. So male are covered fully, and also female are covered fully. So, okay, let's see. Since I don't trust myself, I check this person has 1. It's born in Paperopoli, female, likes computer science. This person has 0. It's female, likes statistics. Okay. Build a new variable called misunderstood equal to 1 yes if the student answered that it does not live with other students, but then answered the mate's opinion question. 0 otherwise. So it's a check on missing value. Okay. You have to write yes if the person has answered 0 to live question and is not missing to the next question. Okay, so it's a little tricky. Let's see. Transform compute. Before doing it, I had promised you that I will show you how to do this with the recode. Okay, let's do it. Transform, recode into different variable. Reset. Okay, how to recode it? Well, let's take favorite subject. ABC2. Change. Okay. Well, if favorite subject is low, which was 6, okay, I will have to assign a value of 1. Oops. Add. Okay. Otherwise, I will assign a value of 0, so all other values 0. But this rule works only for the male subject. So I type if sex equal 1, not 0. Okay. So for the male subject, I apply this rule. Okay, done. And now I will redo it again for the female subject, but changing it, the value of computer science. Now go this one, remove. Okay. Let's see if it works. Yes, it's identical to the other one. So this is an alternative. It's a little contorted, however. It's better to write a logical expression, according to my opinion. Okay, now let's do this one. Misunderstood. I removed these 2 because we will not use them anymore. Transform, compute, reset, misunderstood. Okay, if the person has live with other student equal to no and missing this variable equal to no. In this case, the person has misunderstood our question. In all the other cases, here she has not misunderstood the question. So I could even skip writing what happens to the others, but just to be complete, I write leave with other students equal to 1, or open parenthesis leave with other students equal to 0 and missing mates equal to 1. Okay, just to be complete, I write also the alternative question. Usually the alternative condition is a little complicated if you have an AND here. So leave with other student equal to 0 and missing mates equal to 0, or leave with other student equal to 1. The alternative is leave with other student equal to 1, or leave with other student equal to 0 and missing mates equal to 1. Okay. Okay, misunderstood. Since we will really use this variable, let's fix it. It's a yes, no, so I take it from here, copy and paste. Are there any missing? No, there are no missing. Okay. Very well. It's not scale, it's nominal. Okay. Oh, you can do it at home. Let's see some date exercises. We have already done this, a similar thing. Build a new variable containing the age when element. See this one. Build a new variable equal to the number of practices sport for bachelor student, the number of practices sport multiplied by 1.3 for male master student and by 1.2 for female master student. Number of practices sport, I mean that you must use the variable, you must count these variables here. Okay. So before building this variable, it will be a good idea to count how many sports does the person practice, and you can do it counting the yes in these variables. So before we'll count values within cases. Reset sports target label, how many sports, how many practice sports, variable out sports, define values, 1 add. Okay, so this new variable, which we will keep because, so let's fix it completely. It's a scale, it's a count, so it's scale. Counts how many sports does the person practice. Okay, and now using this variable we have to multiply it by 1.3 for male master student and by 1.2 for female master student. So transfer, let's save. Transform compute variable, reset abc, sex equal male. No, it's better to make where is degree type? Degree type equal to bachelor by sports plus degree type equal to master and sex equal to male by sports by 1.2 plus, and I copy, degree type equal to and sex equal to 1 by sports by by 1.3. Is it what I asked? No, 1.3 for male and 1.2 for female. So 1.3 and 1.2. Okay, done. Let's see. Okay. Some strange values for master students. This is a master student, isn't it? Yes. Okay, I remove it because we don't need it anymore, luckily. Okay, well, I think that the rest could be done as an exercise. Okay, let's see now how to build indexes. Indexes are a sort of a summary, a collection, an indicator of several variables. Usually these variables are scale or ordinal, well, but they may be also nominal. The typical usage, however, is when these variables are ordinal, and you want to sum up everything which the person says. Okay. First of all, indexes are always scale variables. So whenever you build an index take into consideration that you're building a scale variable. Moreover, we will learn to build indices which go from 0 to 1. If you want to go from 0 to 100, just multiply the index by 100, or if you want to go from whatever to whatever, just rescale the index appropriately. Okay, this is the general formula. Okay, this is a weighted index. You can see there's a weight here. Okay, so you build the index summing up the variable value minus its minimum value. This is a little trick to make each variable start from 0. Otherwise, if a variable starts from 1900, well, it's clearly completely different. It will screw up your index. So subtracting the minimum value will let each variable start from 0. Okay, multiply by an appropriate weight, so you may give each variable a different weight, especially if you are comparing things which don't have the same unit of measure. Everything divided by the maximum, the possible theoretical maximum of the numerator. This is it's not really necessary, it's just a trick to make your index go from 0 to 1. Otherwise, you don't know from where to where does your index go. Okay, in case the variables you are considering are all binary, so with values 0, 1, for example, you are building an indexes on a set of yes/no questions. Okay. In this case, this formula simplifies a lot because the minimum is always 0, so you can see it get dropped, and the maximum is clearly the sum of the weight, so it will simplify. It's just in this case a weighted average of the variable values. Okay, let's see some examples. Suppose I ask you to build an indexes which let's write it to make it clear. Build an index from 0 to 1. Build an index from 0 to 1 including these variables. Playing football. Oops, it's a little huge. With weight of 3. Playing basket with weight of 2. Number of passed exams with weight 0.1. I put a small weight here for number of passed exams because compared to this one it's much larger. And university grade with weight of 1. Clearly this index doesn't make sense at all. You are mixing things which are completely different. However, just as an exercise, well, it's very easy. You always build them with compute variable. Let's call them index 1. Okay. Just build a numerical expression. Open parenthesis. Don't forget a parenthesis. It's an often mistake. playing football with weight of 3, so 3 by open parenthesis football minus its minimum, which is 0. Well, it's not necessary to write minus 0 clearly, but I do it just to show you that it must be minus the minimum. Plus 2 by playing basketball minus 0 plus 0.1 by number of passed exams. The minimum of passed exams is 0 plus university grade 1 by minus 1. Pay attention to this minus 1. So university grade has a minimum of 1. Close the big parenthesis, so this is the numerator divided by. University grade has a minimum of 1. Now, divided by, you must calculate the maximum. Usually you calculate the theoretical maximum. In some cases where you don't have any idea what could be the maximum of a variable, for example, year of birth. Well, this year the maximum could be around 1996, or even earlier, no, 1993. Next year it will be 1 year more, so you don't have any idea what the maximum is. In cases like this, you put the practical maximum. So you ask SPSS what is the maximum of a variable and you put it. Okay. But otherwise, if there is a theoretical maximum like university grade, which goes from 1 to 5, you put 5. Okay, here you can calculate with your pocket calculator or with a computer pocket calculator the maximum, or you can write it down. So if you don't want to use the pocket calculator, you can very simply write open parenthesis 3 by football has a maximum of 1, so by 1 plus 2 by basketball has a maximum of 1 plus 0.1 by, in this case, exams has a maximum of 98, we have said. You can also here take the practical maximum, which could be 90, I think, or the theoretical maximum, which is 98. They don't differ so much. Plus 1 by, okay, the maximum of university grade is 5, but pay attention to minus 1, so by 4, so not 5, 4. Okay, again, I say, this calculation could be done with your pocket calculator, and that will be good, but leave access the SPSS do it. Okay, the index is built. Okay, please leave this in at exam, leave this in the output so I can check which formula have you used. If you don't leave it, as somebody does, I will just check the numbers. If the numbers are okay, correct. If the numbers are wrong, completely wrong. If you leave it, instead I may give partial grades. Okay, here the index, you can check yourself, it goes from 0 to 1. Okay. It's 1 only if somebody plays basketball, plays football, has passed 98 exams, and has given the university a grade of 5. Okay. Okay. Let's build an index with a binary variable. Okay, let's build this index. It's very easy. You can use the short formula here. Well, if you want, you can use the long formula, but it's much faster to use the short one. 3 by football plus 2 by basket plus 7 by dt divided by 7, 3, 10, 12. Okay. Straightforward. Here the index 2. It's equal to 1 if somebody plays football, plays basketball, and has passed decision theory. Let's check. This person should pass decision theory, yes. Play football and play. This person plays everything, almost, except volleyball. Okay. It's equal to 0 if somebody has not passed decision theory, does not play football, and does not play basket. Okay, so it's really straightforward. The only thing you have to remember is this calculation of the maximum of the numerator. Pay attention. Pay attention also to the parentheses. These are rather common mistakes. Okay, here there are some exercises. Most of them don't tell you the weight and don't tell you which variable to include. Decide yourself, invent yourself. Okay, let's build this one. I will copy and paste here. Let's look it better. Okay, build an index to measure the participation of the subject in academic activities. Okay, the number of passed exams divided by the mean of passed exams for third degree type. Okay, the situation here starts to get difficult. For this one, we will have to build an appropriate new variable, otherwise you could not do it. Living with other students, the grade given to university, the likeness of the roommate. Okay, this one needs another variable. So for this one, you need, first of all, to calculate the mean of passed exams by degree type. Okay, so I need the descriptive statistics. No, I need compare means. Passed exams by degree type. Okay. Okay, it's bachelor 22.67, master 35.57. Then I need to build a new variable, the number of passed exams divided by either 22 or 35. Okay, so I built this with a wonderful transform compute. Reset. Let's call it exams2. It's equal to if degree type is equal to bachelor, then it's exams divided by 22.67. Otherwise, degree type equal to master, it's exams divided by 35.56. Okay, let's check the new variable. Okay, it measures whether your average of passed exams is, say, more or less the same of your degree type, or much less or much more. This person, for example, has passed many more exams than his degree type. This person much less. Okay, so now we have the variable and we may do the rest. So participation, transform compute variable, reset. Numerical expression, weights 1, we assume that the maximum is 5, is written here, so 1 by exams2 minus, the minimum is 0, because if you have passed 0 exams, you get 0, plus 2, living with other students, 2 by sorry, this is a yes no, so the minimum is 0, plus grade given to university, weight 3 by university grade, minus 1, plus likeness of roommates, weight 1 by think of apartment mates. Building indexes in this way has the main minus 1 disadvantage that if any of this variable is missing, the entire index is missing. Pay attention to the big around parentheses outside, divide by the maximum is, open parenthesis, also here, 1 by maximum of exam2, it's written to assume 5, plus 2 by 1, plus 3 by 4, which is the maximum of university grade is 5 minus 1, 4, plus 1 by mates maximum is 5, so 4. Okay, participation has been done. It goes from 0 to 1. Okay. Okay, the rest is more or less the same. I kindly invite you to do this one. Okay. Which needs also recording, so it starts to be a little interesting.